This is a lesson 11.7. We're going to talk about surface areas and volumes of cones. The first thing I want to do, though, is talk about the difference between lateral surface area and then just surface area. Make sure that we understand the difference between those two things. So I'm just going to begin with a box here. And when we think about this, it's going to have 6 surfaces. Okay, we're going to have front, back. We're going to have a right side and a left side. And then we're going to have a top and a bottom. Okay, and the surface area is going to be the area of all of these surfaces. Okay, all 6 of them. The lateral surface area is only going to be the front and the back and the 2 sides. It's not going to include the top and the bottom. So that's the way you can think of lateral surface area, is it just is the sides of the box. So say, for example, this is a shed or a house or something like that, and you want to paint it. So we need to know how much paint it's going to take to paint all of the shed. Well, we're not going to worry about surface area. We're just going to worry about lateral surface area when we're going to paint our shed, because, I mean, are we going to paint the roof of our shed? Are we going to climb underneath and paint the bottom of the shed? Obviously not. We're just going to paint the 4 sides. So that's the difference between lateral surface area and surface area. Now that's the same idea when you look at a cylinder, a circular cylinder in this case. Okay, we're going to have lateral surface area, which is the area of the sides here, that curved surface as it goes around. And then we're going to have total surface area, which would include the top and the bottom. Now usually we just call each of these the base, and they're interchangeable. It doesn't matter which one's the top and which one's the bottom. We can flip it over. And so if we know the area of one, we know the area of the other. So that's a little bit of a lesson about lateral surface area. And why don't we go ahead and do the surface area of a circular cylinder so you can see how that works while we're at it here. So here I have my circular cylinder. Let's say the radius is 5 and the height looks like maybe might be like 15 or something like that. So we're going to say centimeters, and we're going to find the surface area. Now let's talk about its lateral surface area first. Okay, so what I'm going to show you is just how something can fold up and make a circular cylinder. So I'm just going to start with this piece of paper here, okay, and I'm just going to roll it up, maybe get it close. Okay, so there's our circular cylinder. Can you all see how that works? Okay, so our circular cylinder, we got it all. Okay, and we want to find the area of this surface, this curved surface going around. That seems like that would be a difficult situation. But all we have to do is think about it this way. If we cut the cylinder down the side like that, and so in this case I can just unroll it like this, okay, what do we end up with? We end up with, in this case, a square, but it could be a rectangle or yeah, a little bit more like a rectangle usually. Okay, So that's what I'm going to do, is I'm going to just split this down the side. Now when I do that, this distance right here is still going to be 15 centimeters, isn't it? Okay, but this is going to unroll, going to give us a shape like this. Okay, now let's think about this distance right here. Where does that come from? You can see it's actually the circumference of the circle, isn't it? And the circumference of this circle would be its diameter, which would be 10 times pi. So we have 10 times pi centimeters as the distance across the top of our rectangle. So now we know the length and the width. It's not too difficult to find the area of our rectangle, is it? I'm just going to say 15 times 10 times pi. Okay, now there's that pi thing again, right? I'm not going to get out my calculator. That's the exact area of our rectangle, which is the lateral surface area of our figure. And then I want you to also notice that when we go length times width, we also have centimeters times centimeters, which of course is square centimeters, or area. Needs to be area, doesn't it? Okay, so there's our lateral surface area. And what else do we have? Well, we have the two bases. So I've got the top and then I've got the bottom. Okay, they both have a radius of 5. So the area in each of these cases would just be 5 squared times pi. So we have 25 times pi for this circle, 25 times pi for this circle here. And so our lateral surface area, 150 pi square centimeters. And then our total surface area, where's this going to fit? Total surface area would be our lateral surface area plus the area of each base. So 25 pi plus 25 pi. And you'll notice that these are all like terms, aren't they? They're all going to add up, and we can say 200 times pi square centimeters, and there's our exact answer for our surface area. So lateral surface area, just our curved surface as we go around there, and then total surface area, that includes the two bases. There's a formula that you're given. The surface area of a circular cylinder is 2 pi r squared plus 2 pi RH. And you can just use the formula. You don't even have to know what you're doing. That's the beauty of formulas, I guess. But right here, 2 times pi, that's the diameter, times 2 times r, that's the diameter, times pi, that's this, 10 pi, times h. So you'll notice this is the lateral surface area part. And then pi r squared, that's the area of one base, and 2 pi r squared, that's the area of both bases. So if we did it this way, we would end up with 50 pi plus 150 pi, and remember, they're going to be like terms, just like 50x plus 150x, 200 pi square centimeters. So that's how the surface area of a circular cylinder works.